Now let's look at something that is called visibility modifier or access modifier. So in Kotlin they are called visibility modifiers, and they are the keyword which is used to restrict the use of classes, interfaces, methods, and properties in Kotlin. So what is a visibility modifier? Well, visibility modifiers are the keywords which are used to restrict the use of classes, interfaces, methods, and properties in Kotlin. And these modifiers are used at multiple places, such as the class header or the method body. And visibility modifiers are categorized into 4 different types, which are public, private, protected, and internal. The most common ones are public and private, and you probably have used them already, or at least have seen them already. So let's start with a public modifier. A public modified element is accessible from everywhere in the project. The public modifier is the default modifier in Kotlin. So if any class, interface, etc. is not specified with any access or visibility modifier, then that class or interface and so forth is used in a public scope. So if you add nothing, then that element is automatically public. All public declarations can be placed at the top of the file. If a member of a class is not specified, then it is by default public. So here the same goes as for interfaces and classes and so forth. So let's have a look at the syntax of public modifiers. As you can see, you can make a class public by adding the public keyword, or it is automatically public if you don't add it, but that's generally what you can do. You can add the public keyword to specifically state that a class or a method or a value even, or a field, variable, however, is public. Then the private modifier, and that's where things can become a little more interesting. A private modifier allows the element to be accessible only within the block in which properties, fields, etc. are declared. So if something is private, then it's only accessible where it is declared. All right. So the private modifier declaration does not allow access outside of the scope, and a private package can be accessible within that specific file. So if you have multiple packages and you make one package, for example, private, then this one will not be accessible in other files. So for example, if you have multiple classes and you have a package in one class and you make this package private, then you cannot use it in other classes, which are in other files. All right. So the syntax for a private modifier, well, you can have a class that is private, then you can have its properties to be private by just adding this private keyword, then the methods to be private. And in this above example, you can see that val x and the function do something are declared as private. The class example is accessible from the same source file. Val x and fun do something are only accessible within the example class. So if we now create an object of this class example, we cannot access the variable x and we cannot access the method do something. Okay, so they're really only available within that same class, and this class is only available within that same file. So if we use another file, this class will not be accessible and we cannot create objects of it. Then the internal modifier is a feature in Kotlin which is not available in Java, and the internal modifier makes the field visible only inside the module in which it is implemented. So all fields are declared as internal, which are accessible only inside the module in which they are implemented. All right. So another example here, and we can see the syntax for internal modifiers. So you can use this internal keyword for a class, for a property, and also for methods, and even for global variables, as you can see here. So then there is a keyword called open, and we need to talk about it real quick in order to understand the next concept. So in Kotlin, all classes are final by default, so they can't be inherited by default. Okay, that's different to other programming languages. For example, in Java, it's the opposite, that you have to make your class final explicitly because all classes can be inherited from. So if you want to use inheritance, then you need to make the class that you want to inherit from open. So to make a class inheritable to other classes, you must mark it with the open keyword. And otherwise you get an error here, type is final, so can't be inherited. All right, so then there is the protected modifier with a class or an interface allows visibility to its class or subclass. A protected declaration, when overridden in its subclass, is also protected unless it is explicitly changed. So we're going to look at that in a bit. And the protected modifier cannot be declared at top level. So packages cannot be protected. You can use other visibility modifiers, but you cannot use the protected modifier on packages. So here's an example. You can see here we're using the open keyword, open class base, where we use this protected val I, which we set to 0. So now we have this class which derives from base, so which is our derived class, and there we have this function getValue, or this method to be precise, and it returns an integer. And there we now return I. So we return the variable that was created in the base class. Because we are inheriting from it, we can use it. But if we weren't inheriting from it, so if we're in another class, let's call this class C, then we could not use this val I. Then another example, overriding of protected types. So here we have an open protected value. So now it allows us to override that value. Okay, so now we can override it. We cannot just only use it, but actually override it. So you can see we have another class which also inherits from base, so different to the one that we had before. As you can see, this was class derived, and now we have this class called another. It derives from base. It also has a function called getValue, and then it returns I. But on top of that, it overrides the value I. So here you can see, if you want to be able to override something, you need to add the open keyword to it. So in this case, you need to open the value that we use there, the variable. All right, now we have another example here of the visibility modifier. So we have this open class base. We make it open so that we can inherit from it. Our other classes, like our derived class there at the bottom, can inherit from it. So var A that we define is automatically public because it's public by default, right? We didn't specifically state that it's public, but it is by default public. Then we create this other variable called B, and that one is private. So it's private to the base class. Then we have this protected variable C, and we make it open. So this one is visible to the base and the derived class, which means that the derived class, in this case it's called derived, but this is the case for all classes that are deriving, it's visible there and it's usable there. Then we have this internal val D, which is visible inside the same module, which means that it is visible inside of the same file pretty much. And then we have this protected fun E, which is our function, and it's visible to the base and the derived class. So because it's protected, it's not only visible or usable in our base class, but also in our derived class, but not inside of our fun main. All right, in there it's not visible. So here we have our derived class. A, C, D, and E of the base class are visible. B is not visible. Why is that? Well, because it's private, so it's only available in the base class itself. Protected, internal, and public variables, however, are visible in the derived class. And then we can even override the value C because it's protected, so it can be used in the derived class, but it's also open, so we can override it. Okay, C is protected, but we can override it with the override keyword. Then we have our function main, and in there we have a base object, so we create an object of our base class, and we create an object of our derived class. All right, so when we try to access A and D, we can access them because A is public and D is internal, so it's visible in the same module, and we are in the same module in this example. And then we have base B, C, and E, which are all not visible because they are protected, so they are only visible in the same class or in a deriving class. All right, so B is a private one, so it's not going to be visible anywhere else, right? Except, of course, for the base class. Then we have the value C, which is protected, so it's not visible outside of classes that are deriving and the class itself. And then we have the same for E for our function. All right, and then we have the val derived object And here we're trying to access C, but C is not visible. Why is that? Well, because we are inheriting our value C, we're overriding that value C, but it's still going to be protected. So C is not visible. So this is a little bit much to digest, I can imagine. So no worries, but we're going to use this quite a bit. So we're going to use all of these visibility modifiers when we need them. And most of them we are going to use very sparingly, very rarely. So for example, protected and internal are not used as often as, for example, the private keyword. So we're going to use that one, and step by step they all will become natural. So no worries if that was a little bit much all at once. But I wanted to keep it all together in one video so you can see the different rules there.